Welcome to 3DPL Tutorials, ArchiCAD, Terrain Modeling, the Mesh tool. This is a standalone video and part of the Toolbox series, the Mesh tool. There are various ways of modeling the terrain of your site in ArchiCAD using topographic information from a surveyor. In this tutorial, I will concentrate on the XYZ file. I will look at the file interoperability and how to place a mesh from surveyor's data into ArchiCAD using or making your own XYZ file. When you open an AutoCAD file from a surveyor, it might look something like this. The first thing to do is check the drawing unit setting. In the UK, that unit is set in meters. The drawing will show the position of the existing buildings. It would show the survey points marked with an X, and it would show an AOD above ordnance datum, which is usually mean sea level. The level would be shown in meters. It would also have the extent of the boundary, and there would be a station point. This is a fixed surveyor's point, which is marked on the site with a steel peg or nail. The station would be marked with an X coordinate, a Y coordinate, and a Z level, which is the AOD. Now that we have the topographic information in AutoCAD, how do we get that information into ArchiCAD in the most efficient way? You could ask the surveyor to give you an XYZ file. This would allow you to import directly into ArchiCAD, and you would have a 3D model instantly of the site in real-world coordinates with the correct AOD. I'm going to assume that the surveyor does not have the file you need. If that's the case, you still have all the topographic information you need on the AutoCAD file to make your own XYZ file. All you need is the station point, the X and Y coordinates, and the AOD of every surveyed point. First thing I'm going to do is place a circle with its center directly onto each survey point. Then, and you don't have to do this, but I sometimes connect the points with the same AOD with a polyline. Next, I'm going to place a dynamic text field on every survey point. This means that if I move any survey point, the X plus Y coordinate values will update. I'll zoom in to get a closer look at the next process. Type F on the keyboard and select Field. The Field panel opens. Scroll down in the field names and click on Objects. Then click on the green highlighted icon. The panel will close to allow you to select an object. Then click on the circle object. In the Properties column, select Center. Then in the Format column, I'll keep the current units. You can see what they will look like on the top right. Then make sure the X and Y are ticked and the Z is unticked, as we already have the AODs. Once that's done, press OK and place the coordinates next to the relevant survey point. I'll repeat the process once more. Type F, select Field from the drop-down, select Object, then click on the green icon and select a circle object. In the new menu, press Object, then Center, check X and Y, press OK and place the coordinates. Now I'll place coordinates on the survey point to check if the AutoCAD drawing is in the correct WCS or World Coordinate System. Bear with me, but this is something you should check, and yes, it looks like the X and Y match the station point coordinates. Now we have to place coordinates to each of the survey points. To avoid repetition, I've already done this. The next step is to copy each of the X, Y, and Z figures onto Notepad. Again, I've already done this exercise. You have to place the X value in the first column, then a gap, the Y value in the next column, another gap, and the AOD or spot level, all in meters. You have to copy these very carefully. If one of the coordinate values is wrong, let's say you place a 9 instead of a 6 here, then that coordinate would be out by about 30,000 meters. We are now ready to save these files as an XYZ file, but first I like to copy the values into Notepad++. You can download this free, and it's more powerful and has more features. Okay, so we have the X column, the Y column, and the Z column in Notepad++. Now to save it. Press File, Save As, and select All Types. Then change the name to end in .xyz and save it to your folder. Now we can open ArchiCAD. I've drawn a line on the project origin, which is set at x equals 0 and y equals 0. And the first thing I'm going to do is open Project Preferences and check the working units and set to meters. Next, I'll create a new independent worksheet and name it Topography, then open it. Then I'll switch on Trace, click on Choose Reference, and select Ground Floor as the reference. Once that's done, still in Worksheet, I'll open File and click on External Content, then Place External Drawing. A menu will open. I saved my AutoCAD Topo file here. I'll click on it and press Place. The drawing will be placed into the worksheet. Now I'll select the drawing, zoom in, and move the topo drawing so that its station point is on top of the project origin. So at present, the station point is on project origin, which is x equals 0 and y equals 0. I now have to move it to the correct coordinates. Select the drawing, then right-click and press Move, then press Drag. Type X and type 260,000 for the X dimension and 500,000 for the Y dimension and enter. The drawing will disappear from view. Next, I'll close the worksheet, open the ground floor, and delete the line I drew as a guide. I'll check the Show Survey Point. Then click on the arrow to show its settings. Select Show Survey Point Coordinates. At present, they're set to 0.0.0. In Settings, select Location Settings. And in the Survey Point Position box, type 260,000 as the northing and 500,000 as the easting. Press OK and the survey point will disappear. Now press Zoom to fit to window. And if you zoom in further, you should see that the X and Y coordinates match. I'll open Trace Reference Settings, select Trace Reference and change the color. Next, open File, scroll down and click on Interoperability. Then click on Paste Mesh from Surveyor's Data. Then you have to find the folder where you saved your XYZ file, click on File Type and select .xyz. Now click on Coordinates XYZ. Check the scale, then you can either place the mesh where you want it or place it in its correct coordinates. I'll choose its exact location and press OK. The 3D topographic model will then be automatically placed in its correct location with its levels at the right heights above mean sea level. I'll switch off Trace and zoom to Fit window. The mesh shows all the spot levels and how they are connected to each other. If I select the mesh, I can click on any point and check its level by clicking on the Z height. It reads as 24 meters AOD. That matches our data. I'll check another by clicking on the Z height, and it reads 30 meters AOD. That also matches our data. Now, if I right-click and open the mesh settings, you can arrange any of the settings, but there is one I want to highlight. That is the ridge selection. You have the choice of selecting Show All Ridges or User-Defined Ridges. I'll select the latter. If I scroll down, I might want to change the surface texture or the colors and the line weights. I'll press OK, and because I've selected Show User-Defined Ridges, the mesh lines have been hidden. I'll press Ctrl+Z to go back to the Show All Ridges. Next, I'll right-click and select Show All in 3D. And here we have the mesh showing all ridges, which you can hide by selecting the mesh and going to Settings, and in the Model section, select Show All Ridges Smooth. You can revert back to Show All Ridges, as it is useful when cutting and shaping the mesh. Now you can continue to work on your terrain mesh. Try placing a floor slab on the mesh and cutting the mesh around it using solid element operations. Select the target, then add it, then select the operator and add it. Then select subtraction with upward extrusion, then execute. Thank you for watching. This brings us to the end of the advanced mesh tutorial. Please press the like button, subscribe, or watch my other tutorials.